Welcome to this comprehensive guide on classes and objects, fundamental concepts in C# programming. These concepts are absolutely essential for anyone looking to develop applications in Visual Studio or create games and interactive experiences in Unity 3D. Understanding them forms the bedrock of object-oriented programming, which is a core paradigm in modern software development. To grasp the concept of a class, imagine a detailed blueprint for a car. This blueprint isn't a car itself, but it meticulously defines every aspect of what a car is. It specifies its properties, such as its potential color, the specific model, the number of doors, and the type of engine it will have. Furthermore, it outlines what the car can do, detailing its behaviors like how it accelerates, how it brakes, how it turns, and even how its lights operate. This blueprint is a comprehensive design document. In the world of programming, this blueprint is precisely what we call a class. A class serves as a meticulously designed template or a master plan for creating objects. It acts as a formal definition, outlining the characteristics, which we refer to as properties, and the actions or capabilities, known as behaviors or methods, that any object created from this class will possess. It's the foundational structure from which all instances will be built. Now, taking that car blueprint, when you actually build a car from it, giving it a specific color like a vibrant red, a particular model such as a Sedan X, and a unique vehicle identification number, that tangible, physical car is what we call an object. It's also frequently referred to as an instance of that car class. This object is a real-world manifestation of the abstract blueprint. Objects are the concrete, tangible entities that come to life within your program. Each object, created from the same class blueprint, exists independently and possesses its own unique set of data. For example, while all cars have a color property, one car object might be red, another blue, and a third silver, each holding distinct values for that shared property based on a class definition. Let's dive into the practical application of these concepts. We'll begin our journey by exploring how to define and effectively utilize classes and objects within the structured environment of a C# console application, all managed through the powerful integrated development environment of Visual Studio. This will provide a solid foundation for understanding their implementation. Our first step will be to create a brand new C# console application project within Visual Studio. This particular project type is ideal for learning as it provides a straightforward and basic structural framework for our code, allowing us to focus purely on the concepts of classes and objects without the complexities of a graphical user interface. It sets up the necessary files and configurations automatically. Once our project is set up, we will proceed to define a simple class. For demonstration purposes, we'll name this class Person. This Person class will encapsulate fundamental characteristics, including properties such as name, which will store a string value, and age, which will hold an integer value. These properties will serve as attributes for any person object we create. These properties, like name and age, are essentially specialized variables declared within the class. They are designed to hold specific pieces of data that are unique to each individual object created from this class. Think of them as distinct data slots that define the state or characteristics of each particular instance, allowing each person object to have its own name and age. Beyond just properties, we can also imbue our person class with behaviors by adding methods. For instance, we can include a SayHello method. This method defines an action or a capability that any person object can perform, such as printing a greeting to the console. It encapsulates the logic for how a person object interacts or behaves. Now, within our main program file, typically program.cs, we will proceed to create an instance of our person class. This act of instantiation effectively brings a person object into existence in our program's memory. We'll declare a variable, for example, person1, and assign it a new person object, thereby creating a concrete entity from our class blueprint. Once we have our person1 object, we can then access its properties and assign specific values to them. For example, we can set person1.name to the string value Alice and person1.age to the integer value 30. This process populates the object's data fields, giving this particular person instance its unique identity and characteristics. Finally, to observe the behavior we defined, we will call the SayHello method directly on our Person1 object. This action demonstrates how objects execute their predefined behaviors, in this case, printing a personalized greeting to the console. It showcases the dynamic interaction between an object and its methods, bringing our class definition to life. A highly valuable tip for working efficiently in Visual Studio is to leverage its powerful IntelliSense feature. IntelliSense provides intelligent code completion, offering suggestions for properties and methods as you type. This significantly speeds up development, helps you discover available members, and drastically reduces the likelihood of syntax errors, making your coding experience much smoother. Understanding constructors is a pivotal aspect of working with classes. Constructors are specialized methods within a class that are automatically invoked the moment an object of that class is created. Their primary purpose is to initialize the object state, ensuring that all properties have meaningful default or specified values right from the start, making the object ready for use immediately after instantiation. By utilizing constructors, we gain the ability to set the initial values for an object's properties directly at the point of its creation. This not only makes our code more concise and readable by consolidating initialization logic, but also enhances efficiency by ensuring objects are always in a valid state from the moment they are instantiated, preventing potential errors from uninitialized data. Having established a solid understanding of classes and objects in a console application, let's now seamlessly transition our knowledge into the dynamic environment of the Unity 3D game engine. In Unity, these fundamental concepts are not just important. They are absolutely central and indispensable to every aspect of game development, from character control to game logic and UI management. In Unity, C# scripts are not just standalone code files. They are inherently classes. What makes them special is that they typically inherit from a base class called MonoBehavior. This inheritance is crucial because it allows these script classes to be attached directly to game objects within your Unity scene, enabling them to control and define the behavior of those game elements. Game objects are the foundational and most fundamental building blocks that populate your entire game world in Unity. They represent virtually everything you see and interact with, from player characters, non-player characters, and environmental props to lights, cameras, and even invisible managers. Each game object is an entity that can have various components, including our C# scripts, attached to it. To illustrate this, we'll create a simple C# script. For instance, we'll name it Player Controller. The purpose of this script will be to encapsulate the logic required to manage and dictate the movement and interactions of a player character within our game scene. This script will serve as the blueprint for how our player behaves. This Player Controller script, functioning as a class, will be designed to contain specific properties, such as a move speed variable, which will determine how fast our player moves. Additionally, it will include essential methods, like the update method, which Unity automatically calls once per frame, making it ideal for implementing continuous game logic, such as movement input processing. To bring our script to life and make it functional within the game, we must attach it to a game object in the Unity scene. By dragging and dropping our Player Controller script onto a game object, we effectively transform that game object into an instance of our Player Controller class. This action links the script's logic directly to the visual and physical presence of the game object. Once our Player Controller script is successfully attached to a game object, that game object immediately inherits and possesses all the properties and behaviors that we meticulously defined within our script. For example, it will now have a move speed property and will execute the logic contained within its update method, making it a fully functional game entity. A powerful feature in Unity is the ability to directly modify the move speed property and other public properties right within the Unity Inspector window. This demonstrates how object properties are not only defined in code, but are also conveniently exposed and adjustable in the editor, allowing designers and developers to fine-tune game parameters without needing to alter the underlying C# code. Now, let's enhance our Player Controller script by adding some fundamental movement logic within its update method. This logic will enable the player to control the game object using various input mechanisms, such as keyboard presses. We'll implement code that translates player input into actual movement, making our GameObject interactive and responsive. Upon running the game, you will now observe our GameObject dynamically responding to your input. This responsiveness is directly driven by the movement logic that we meticulously defined and implemented within our C# class. This real-time interaction vividly demonstrates how code translates into tangible gameplay, bringing our game elements to life. Here's a highly useful Unity tip. By declaring variables as public within your C# scripts, you automatically expose those properties directly in the Unity inspector. This invaluable feature makes them easily configurable and adjustable by designers and developers without the need to delve into or modify the underlying code, streamlining the iteration process significantly. Another crucial tip for maintaining a clean and efficient Unity project is to meticulously organize your scripts into meaningful and logical folders within the project window. Creating dedicated folders, such as scripts, models, or materials, helps maintain a structured and manageable project hierarchy, making it much easier to locate, manage, and collaborate on your game assets. Beyond basic GameObject control, classes and objects are also absolutely crucial for creating sophisticated custom components and intricate systems within Unity. This capability allows you to extend Unity's built-in functionality, tailoring it precisely to the unique requirements and complexities of your specific game, enabling highly specialized and optimized game mechanics. For instance, you could design and implement a dedicated health system class. This class would be solely responsible for managing a character's health, including properties like current health and methods such as take damage or heal. This system would operate independently from, say, their movement logic, promoting clear separation of concerns and modularity in your game's architecture. This modular approach, which involves using distinct classes for different functionalities, offers significant advantages. It inherently promotes code reusability, as individual components can be easily integrated into various parts of your game. Furthermore, it greatly simplifies maintenance and debugging, as changes to one system are less likely to impact others, leading to a more robust and scalable codebase. In summary, the core distinction is clear. Classes serve as the abstract blueprints, meticulously defining the properties and behaviors that objects will possess. In contrast, objects are the concrete, tangible instances that are brought to life from those blueprints, each with its own unique set of data and capable of performing the actions defined by its class. Within the Visual Studio environment, you meticulously define classes to establish the structure and capabilities of your program's entities. You then proceed to create objects, which are instances of these classes, to logically organize and manage the data and operations within your console applications, building a robust and maintainable software architecture. Conversely, in Unity 3D, C# scripts function as specialized classes that inherit from monobehavior. These scripts are then strategically attached to game objects, effectively imbuing those game objects with specific functionalities, behaviors, and data. This mechanism is fundamental to how you bring interactive elements and game logic to life within your Unity projects. Mastering the concepts of classes and objects is not merely an option, it is a fundamental cornerstone of C# programming. This mastery empowers you to construct incredibly robust, scalable, and maintainable applications in games, laying the essential groundwork for advanced programming techniques and complex software design patterns. It's a skill that will profoundly elevate your development capabilities. We strongly encourage you to continue practicing these essential concepts diligently in both Visual Studio for general application development and Unity 3D for game creation. Through consistent application and experimentation, you will rapidly develop the expertise to create increasingly sophisticated, interactive, and engaging experiences, pushing the boundaries of what you can build.